So let's find the definite integral of these two functions, and I'm going to do this whole section without access to a GDC. If you want to see how to do this with a GDC, in a later video I will do an example of that. So what we want to do to find the definite integral is first of all get the indefinite integral, and then we want to substitute our endpoints into that and subtract them. So very first step is going to be to integrate 2 cos x. We know that the integral of cos of x is negative sine of x, and so the integral of 2 cos x is negative 2 sine of x. And we want to know that integral from 0 to pi on 4. Substitute those values in, and then subtract. Okay, at this stage, might be easier to leave brackets in. Sine of pi on 4. Okay, well, that's an exact value triangle. Sine of pi on 4, 1 on root 2. So, negative 2 times 1 on root 2 minus negative 2. Okay, what's sine of 0? If we go to a unit circle, sine is the y coordinate. The y value there is 0. Okay, so we've got negative 2 on root 2, or negative root 2 if we rationalize that denominator. That's example A. For example B, integrating this is a little bit more complicated. So what we need to recognize here, actually before I do that, is that we have the integral from pi on 4 to pi on 2 of sine of 2x multiplied by cos of 2x cubed. And again, with calculus, I think it's better to put trig functions in this notation than this notation, but you must recognize what that means. So, looking at that, you should be able to see that we have an inner function and an outer function cubed. So we're going to define u as cos of 2x. If we do that, du dx, derivative of cos is negative sine, multiplied by the derivative of the inner function, 2. Alright, so what we're working with then, to get to sine of 2x, we're going to have to multiply this by negative 1/2. And then we're in a position of being able to say the integral from x equals pi on 4. This is actually important notation because we don't have only x as our variable here anymore. So we've got negative 1/2 du dx multiplied by u cubed. My apologies, that should be dx. Okay, so tidying that up a little bit, we have negative 1/2 u cubed du, because these are opposite processes and effectively cancel out. So, where are we at with that now? Well, we can quite easily integrate this. The integral of u cubed, we are going to add 1 to the power and then divide by the new power. plus c is not required with definite integrals. Note I didn't do it in the previous one either. That's because it's going to cancel out. Alright, so we're up to here now. That is negative 1/8. And let's put u back in. U we defined as cos of 2x. And we can get rid of the x equals because now we're back with x as our pronumeral. Right, and then from there, it's simply a matter of substituting those in. Cos of, so if we put pi on 2 in, it should always be the upper bound that goes in first. 2 times pi on 2 is pi. Minus, then we're going to substitute in pi over 4. Pi over 4 times 2 is pi over 2. Okay, using your knowledge of the unit circle, cos of pi is negative 1, and cos of pi on 2 is 0. And so that's negative 1/8. Don't be alarmed by a negative solution. Definite integrals can be negative. It's areas that cannot be negative, and that's the subject of a different video.